right, so yesterday we saw the Venn diagrams and then the tree diagrams. How can you tell the difference? What keyword do we look for Venn diagrams? Both. And then the tree diagrams, there isn't really like a key word, but there's a trigger that you can tell. Is it'll say 1% of some information, and then it'll do like a follow-up of that same previous information. Like here, for example, I said public schools, and then it gave you a follow-up for public schools. So that gives you a clue that it branches off of the previous statement, okay? So was there evidence of the freshman chances to graduate may depend about what kind of school they attended? Well, yes, we can see that because if they went to public school, they graduated 75% of the time, versus if they came from another school, they were able to graduate 90% of the time. So yes, that is proof, or not proof, but evidence that it depends on what school you come from, okay? Part B says, what percent of the freshmen eventually graduate? So you have to calculate the percentage of graduating from a public school and the percentage of graduating from another school, and then you have to add those together, okay? So there's two pathways to graduate. So graduating, you can graduate if you come from a public school, and then you can graduate if you come from another school. So what you're going to do is, if you follow the branch, you multiply, okay? So the branches, you multiply. The probability of graduating, you're going to take the probability of attending a public school and graduating, and then you're going to add the probability of attending another school and graduating. And you're going to follow the branch. So what's the probability of coming from a public school? On my tree diagram, the public is what percent? 70. And graduating is what percent? 75. So because that's an and, you went to public school and graduated, you multiply. And then this is or, you can graduate from going to another school. The probability of going to the other school was 30%. And graduating, if you went to an other type of school, was what percent? 90. So you're going to take those two together and you're going to add them. So take your calculator. I forgot to say, if you have a calculator, please take it out. I know yesterday I told you to have your calculator out, but we didn't really use it. But today, for sure, you need your calculator. I have extras if you guys need your calculator.
Can you give me a Game Boy too?
A Game Boy?
You don't mind having a Game Boy though? That would be cool. Nintendo, bro.
Okay, ready? So go ahead and calculate that. You're going to do 0.7 times 0.75. And then you're going to add 0.30 times 0.90. You should get like 0.795. You're like, huh? 0.795. Which is about like 79.5%. Yes. Question?
Where do you buy the charger for these? Because I kind of love them.
Yeah, I don't know. Try Amazon.
Yeah, I'm gonna check out Amazon.
I think at the school, I don't know if, like, I think they charge $10 if you lose it, but I don't know if it's like $10 to get a new one. I don't know, but
I'll buy new.
You can try Amazon. I don't
I
know.
lost it.
Woo. Okay. That's another thing too. Like, if your calculators just don't work, you need to go exchange it at the library because the calculators you guys have are very outdated. They're maybe like 6 to 7 years old. So some of them, the charger doesn't work. Some of them just need to get replaced, the battery.
They're all just.
Yeah.
When do we use everyone?
When they basically all run out. I don't know. They like gradually like replace some of them. But they're so expensive. They're like $150 each one. So like
They're paying $50,000 for us to take out their hands.
yeah, like that whole like 10 is like $1,500 right there. So
Why did they expect us to buy that for ourselves for 1 year school?
no, that's why they give it to you.
Well, why would they? Is what I'm saying. Like, they gotta buy it for us.
Okay. All right, let's look at part C now. Sorry, we keep going on like tangents, so I apologize.
No worries.
Okay, focus. Part C says what percent of students who graduate from college attended a public high school. So that is a conditional statement right there. What is my condition? That they graduated or they came from a public high school? So it's what percent of students who graduate. So I'm telling you they graduated. What percent of the graduates came from public high schools? So the condition is actually who graduate is the condition, okay? Because it says what percent of people who graduate. So we're only looking at the graduates. So that's the condition. So this is the probability of attending a public high school given that they graduated. So it's going to be the probability of sorry, I'm just trying not to go on tangent anymore. So of going to public school and graduating over the condition always comes second. You're going to take the probability of graduating total. Okay, so the public and graduating, that's basically this again, 0.70 times the 0.75. Because going to public school was 70% and then graduating was a 75%. Over the probability of graduating, we just calculate that in part B. Probability of graduating was this 0.795. So you're going to go grab your calculator and you're going to plug that in. Whenever it's a fraction, I like to make a fraction. So to make a fraction, you just do control divide. And it does the little fraction, control divide. And you do 0.7 times 0.75 over the 0.795. Enter. You should have like 0.660377. So this is 0.66037. I don't know what I just said, but whatever. So that's about 66%.
How can you use the 0.795 from part B?
Why? Because that was the representing the probability of graduating, which is what we calculated in part B.
Okay.
Hey, I remember you.
Oh, yeah.
How's it going?
Good, yourself?
Good.
Smitty?
Yeah, Burles, it's 2:30.
Smitty.
Okay. Bye, nice seeing you. Yes.
Bring my thing.
All right, so We only have 2 more things to go over, geometric and binomial distributions. I will say this, geometric and binomial distributions, I normally spent like about a week and a half to 2 weeks on these 2 topics alone. But obviously we don't have that time. This is going to be all new information to you guys. We're going to learn it like in half an hour instead of like 2 weeks, okay? And then I will say on Monday it's all going to be practice problems. So we'll go back to you guys working on groups on Monday, okay? But on the AP exam, probability is about like 25% of the exam. So it's a big chunk of it. But I will say the probability usually shows up on the multiple choice section, okay? Because a lot of it you can just do it on the calculator. It's just knowing what functions to use, okay? So let's talk about this. The geometric probability, I'm going to use green. Geometric probability distribution, you have to have some requirements here. So it must be a Bernoulli trial, and I'll explain what that is right now. So this is a Bernoulli trial, and I'll explain that in a second. Whoa, sorry. So what is a Bernoulli trial? A Bernoulli trial just means you need to have 2 outcomes and 2 outcomes only. So like for example, if I were to try to hit a ball with a baseball bat? With a bat? I don't know, I couldn't say that for some reason. If I'm playing baseball and I try to hit the ball, I only have 2 outcomes. I'm either going to hit it or I'm not. At a basketball game, if I throw a free throw, I'm either going to make it or I'm not. So I only have 2 options. You have a probability of success and you have a probability of failure, okay? So that's what a Bernoulli trial is you have 2 outcomes. One of them is a success and the other is a failure. And then a Bernoulli trial also, they need to have independent events. Meaning, it doesn't matter what happened previously, it's not going to affect the next outcome. For example, if I make a free throw, the next time is not going to get affected just because I made it the first time. Okay? That's independent events. And then for geometric probability, you are looking for the first success in the nth trial. What is this? Sorry, let me check what the book calls it. The book calls it, first success on the nth trial. Okay, so for example, if we look at the context at the bottom, the context, nth trial, like first, second, third, fourth, fifth. So that's nth trial. For example, if we look at the bottom, it says, what's the probability that her first bullseye is on the 3rd arrow? So I see the word first, success. Those are your key words that tells you it's geometric. The first success and the nth trial. That tells you that it's geometric. And then we have formulas. So success is on the kth trial. On the AP exam, you guys will get a formula sheet. Your formula sheet is going to look something like this. I normally give this to you guys every year, but I don't know. Obviously, I couldn't give it to you guys when you were at home. So I didn't really have them printed for you guys. But on the AP exam, you're going to get a copy of these formula sheets. So on the formula sheet, you'll be able to find all of these formulas. but nothing is labeled. They just give you a whole bunch of random formulas, but they don't tell you what each formula is for. So you need to be able to see it and recognize what formula it is. Okay? So the formula for geometric probability. Yeah.
We get those papers like on the day of exam day?
Yes. So this is the probability of x equals k. Is going to be 1 minus p to the k power times p. But in my class, what do we use for 1 minus p? What is 1 minus p usually? What do we?
Yeah.
What is it?
I thought that was a P instead of a 1. Minus.
1 minus p.
Come on, Silo, we can program.
But 1 minus p, we use q normally in this class. We've always used q, so that's what that. Q is 1 minus p, okay? So this is the same thing as q to the k power times p. All right. And then we have the average for calculating, we have a formula for calculating the average. The mu is 1 over p. And then the standard deviation is our sigma is equal to the square, on the formula sheet, you'll see it as square root of 1 minus p over p. But again, that's going to be the same thing as the square root of q over p. All right, and as a reminder, what does P and Q stand for? P is going to be probability of success. And then our Q is going to be the probability of failure. All right, so let's look at example 1. It says, suppose an archer can hit a bullseye 70% of the time. And then we're going to assume each shot is independent of the other. So what's the probability that her first bullseye is on the third arrow? So because of the keywords right here, first bullseye on the third arrow, that tells you that it's geometric. My 70% right here is she can make it 70% of the time. So that's my P, the probability of success. 0.7. And then P and Q have to add up to 1. So what would Q be? 0.3. Okay, so this particular person, we're asked to find what's probably she's going to make it the first time on the third arrow. So the first and the second shot, she's going to miss, and then she'll make it on the third. Okay? So this is the, oh my God, what happened? Where'd it go? Here. Sorry. So this is going to be the probability of miss. Then she's going to miss. Then she's going to hit the bullseye. Okay? So miss, miss, hit. What's the probability she's gonna, oh my God, why does it keep doing that? It doesn't like me today. What's the probability that she's going to miss?
0.3.
0.3. And she's going to miss the second one. And it means multiply. And then she's going to make the third one. So that's 0.7. Which I can rewrite that as 0.3 to the second power times 0.7. That is how the formula works over here. The probability of failures, which is Q, raised to the number of failures, times the probability of success. So on your calculator, you can just type that out to calculate that probability. 0.3 squared times 0.7. Citlali said that's 0.063. Ja. Okay, thank you very much. So this is about 6.3%. So that's just typing it out straight into the calculator, 0.3 squared times 0.7. There is a separate way to calculate it, and I'll show you just because we're going to be using the calculator today, the TI Inspire. This is going to be a geometric PDF. PDF because it's only, like, it's an exact thing on the third trial, okay? So what I want you guys to go is you're going to do on the calculator, you guys are going to click on menu. Then you're going to go to stats. Then you're going to go to distributions. And then you're going to scroll down until you find geometric PDF. Okay? So go to calculator, menu. Stats is option 6, distributions is option 5, and then scroll down until you find geometric PDF, which I think was H. Yes, geometric PDF is option H. Oh my god, those. Okay, good. It's going to ask you for probability of success. That is her success rate, which is 70%, and X value. On what shot is she going to make it? She's going to make it on the third shot. So you put 3 and you press OK. And you get the same answer. 0.063. So menu, stats, distribution. Okay. When they ask you for probability of success, that's her success rate is a 0.7. And then the X is on what shot is she going to make it? She's going to make it on the third shot. So you put a 3. And that'll give you the same answer as if you just type out 0.3 squared times 0.7. Did you put 0.7 for? And you put 3? Yeah. Okay. You're probably like, well, that's not useful because I could just type 0.3 squared times 0.7. Yes, I know that's easier to just do 0.3 squared times 0.7. But we're going to start using the CDF, which is going to have a range of values versus just one. And that will be helpful to use a calculator. All right, let's look at the next example.
Damn, Mr. Holy. I'm paying attention to this. I'm gonna rock this please, yeah.
Okay. So question number 2. What's the probability that her first bullseye is on the 5th arrow? So again, because it says the first on the 5th, it tells you that that's a geometric function. And it only gives you one value. It's on the 5th. So because it's one value, then this is a PDF. I don't remember what the P stands for. But I think D stands for distribution. And I don't remember what the F stands for either. But so same thing. This is the probability. She's not going to make it until the 5th arrow. So what's going to happen in the first 4? She's going to miss it. So this is 4 misses and 1 hit. So what's the probability of missing? 0.3. Because success is a 0.7, so failures is a 0.3. And how many times is she going to miss it? 4. So you raise it to the 4th power. And then she's going to hit it on the 5th. So that's a 0.7 because she's going to hit it. Hit the bullseye. So again, you can do 0.3 to the 4th times 0.7, or you can do geometric PDF. Probability of success is still 0.7, but for X, you're going to put 5 because it's for the 5th arrow. So calculate that for me. It should be small, like 0.00 something. 0.00567.
Oh, it's closer to the power button.
All right, so as a percent, this is like a 0.567%. It's less than 1% of that happening versus in the third was like a 6%, so it's higher than if it is on the 5th.
How do I put it back down after I put the
You put the side arrow. Like on the little square. On the square, you put the side arrow. You know where you select? Like, I don't know. Like this arrow.
Oh, right here. Oh.
Okay.
Okay, got it.
Yeah? All right. For question number 3, we're going to change question number 3. All right. Can I have you guys pay attention up here, please? I'm going to have you guys change question number 3. We're going to cross out the beginning. Suppose she makes 3 bullseyes in a row. We're going to cross that out. I'm going to change the question because when I printed these, I didn't print a geometric CDF example. So I'm just going to change this question. What's the probability that her, instead of next, we're going to say her first bullseye will be, and we're going to cross out the on her 5th arrow. We're going to say, what's the probability that her first bullseye will be among the first 3 shots? Okay, so that means she can make it on the first shot, she can make it on the second, and she can make it on the third. These are my 3 options. So notice I have 3 values this time. So because it's 3 values, so this is a CDF. It's cumulative because I have a range of values. Okay, so because of the first success, this tells you that this is a geometric. And because this is the among the first 3 shots, that's a range of values. So that tells you that this is a CDF example. It's a range of values. So this means that she can make it, the probability of making it on the first shot, or the second shot, or on the third shot. So if she makes it on the first shot, what's the probability of making it? What is it? 0.7. She's not going to miss any, so then you just stop there. It's 0.7. She made it. Or means we add. It can happen on the second shot. So it means miss, hit. So the miss is 0.3 times the hit is a 0.7. Or it can happen on the third shot. Or she can miss the first 2, so 0.3 squared times making it on the third. So you could type that whole thing out into the calculator, 0.7 plus 0.3 times 0.7 plus 0.3 squared times 0.7. Or we're going to use geometric CDF on a calculator. Okay? So let's walk through that together. So this is still menu. Stats, distributions, but instead of geometric PDF, you're doing CDF, okay? So menu, stats. You can either scroll down to stats or you can just click on the 6 because 6 is stats. And then distributions is 5, so you can just click on 5. And then you want geometric CDF, so scroll down to CDF, which is I. Geometric CDF is I. It's going to ask you still for probability of success, so that's still a 0.7. But the lower bound, notice I'm saying it can happen between the first three, so first, second, and third. So the lower bound is, 1. And then the upper bound is up to the third shot. So it's among the first three, so between 1 and 3. If the question had said, what's the probability she'll get it on the third or fourth shot, the lower bound would be 3, and the upper bound would be 4. So you should have had like 0.973. Okay, so 0.973, which is about like 97.3%. But again, you could have typed that whole thing out, 0.7 plus 0.3 times 0.7 plus 0.3 squared times 0.7. But it's faster if you just do geometric CDF. Did we? I don't know. Maybe. Last question for geometric. The question is, how many arrows do we expect her to use before she hits her first? So before she hits her first bullseye. So because of the word before she gets her first, that tells you it's geometric. And then the word expect tells you you're looking for the mean. How many arrows do we expect? That means you're looking for the average. So my formula for mean for geometric is 1 over P. And P is my probability of success, so that's 1 over 0.7. So you just put that in the calculator, and we do not round up or down to the whole number. You leave it as a decimal. You can round the decimal, but don't round to the whole number. Yeah, so you get 1.428, so we can say that's about 1.43. You can round there, but don't round up to 2 and don't round down to 1. This is 1.43 arrows. We would expect her to make her first bullseye in about 1.43 arrows. All right, the binomial probability, this is where a lot of people tend to get confused or like, I don't know, but binomial is just, it's a little bit more complicated. So binomial probability, we still have the same like requirements. It still has to be a Bernoulli trial. So remember, a Bernoulli trial just means you need to have 2 outcomes, 1 success, 1 failure, and they need to be independent events. And this time we're looking for like K out of N successes. So this is K successes in N trials. K successes in N trials. So the key words, normally, like, I'll put this here, like the key words that tells you it's binomial, you're usually going to see the words like out of. For a geometric is the first success. But for the binomial, you'll see the words out of. So like 3 out of 6, 5 out of 10. And then my formula is like super complicated. Well, it just looks complicated, but I don't think it's very complicated. This is the probability of this capital X equals K. is going to be N choose K times the probability of success raised to the number of successes, so P to the K, times the probability of failures. On the formula sheet on the AP exam, it'll show up as 1 minus P to the N minus K. But I don't like using that one, I use the Q. So this is the same thing as N choose K, P to the K times Q to the N minus K. You're like, what the heck? Okay.
So
Hi, Judge. Okay, so. No, it's not. Look, I say it all the time. That's why I put I judge. Well, I used to say it a lot. I don't know. Okay. N is the total. And then K is the number of successes. Like number of successes. And then P stands for, so K is up here, so that's still number of successes. And then P, we talked about, that's the probability of success. Q is the probability of failure. And then N minus K is the number of failures. Oh, I just didn't write it because it's the same. It's the number of successes. So I know that looks super complicated, but I promise it's not that complicated. Okay, I still see some of you writing. Okay, let's look at the formula now for mean. Hopefully you guys got that, because I moved it. You guys still need it? I'll shrink it, but I don't know if you can see that still. Okay. There. Okay, so the formula for the mean is the mu for the binomial is N times P. The geometric is 1 over P, but for binomial, you take the N times the P. And standard deviation is the square root of, on the AP exam, the formula sheet, it shows up as N times P times 1 minus P. But again, 1 minus P is just Q. So this is N times P times Q. All right, so let's look at an example of when you would see this. It says, example, a basketball player has made 80% of her foul shots during the season. So assume that shots are independent. Find the probability that in tonight's game she does those 3 things. So what's the probability she makes exactly 5 out of 6 foul shots? So the key words right here, out of, tells you that this is going to be binomial. And because of the word exactly is one value, exactly 5, one value. So this is PDF. So my formula is going to be 6 choose 5. So the 6 is the N. That's the number, the total shots. She has 6 total shots. And her number of successes is 5. That's K. So this is going to be N choose K. So N is 6. And my K is 5. So 6 choose 5. And that's not a fraction. That's not 6 over 5. That's 6 choose 5. So this is how we're going to just think about it as the probability of success is what? Oh, we didn't talk about that. So what is P in this example? 0.80, which means Q has to be what? 0.20 or 0.2. So the probability of success is the 80%. So probability of success is the 80% raised to the number of successes. So how many successes did she have? 5 times the probability of failure, which is 0.20 raised to how many failures? 1. So that's something I forgot to say too over here. Sorry, I scrolled over, but the two exponents have to add up to n. So these two right here, like the 5 and the 1, they have to add up to n, 6. Well, I don't want to put the line there because it's not a fraction. But just know that they add up to n. Okay, so on the calculator, you're going to go find binomial PDF on the calculator. And I think that's option A. So menu, stats, distribution. And I think it's option A, binomial PDF. Menu, stats, distributions. Binomial PDF, yes, that is A. So what's the total amount of shots? 6. Probability of success is different problem, 0.8. And how many shots is she going to make? 5. And then you just press OK. So this ends up being 0.393, which is about 39.3%.
I'll let you get it.
X is how many she's going to make. So she's going to make 5 out of the 6.
6 and 3.
Possibly. Except this one, part B. Sorry, you guys good? I don't know if I'm going too fast or too slow. I don't know.
I mean, if I get it, I'm pretty sure they'll question.
Oh, man. Okay, so what's the probability she makes at least 3 out of the 6? So my keyword, again, out of, tells me this is binomial. And at least 3. That means she can make 3 out of the 6, 4 out of the 6, 5 out of the 6, or 6 out of the 6. You have a range of values, so it's CDF. Good. This is now going to be binomial CDF because you have a range of values. Oh my God. Okay, so this is going to be the probability of making 3 shots, 4 shots, 5 shots, or 6 shots. Have a good weekend. All right, so on here, I'm going to give you a warning. You're going to have to, no, not you. Like, I'm in the class, okay? You're going to have to do this like 4 times. So if you write big, don't write big because
Thank you, Miss Biggs.
I appreciate the
I
warning.
appreciate that.
I don't know if you're being sarcastic.
No, girl, because last time when we did the tree, you didn't
Okay.
put the word and then we wrote it off.
No worries, Miss Biggs.
So I'm just, because this, you're gonna have like a long string of things right there. You're gonna have to draw that thing 4 times, okay? So I'm giving you a heads up. Okay, so the first option is that she makes 3 out of the 6. So this is gonna be 6 choose 3. So you need the probability of success, which is what? 0.8. To the, how many is she going to make? 3. Times the probability of failure, raised to the number of failures, is going to be 3. Good. Or She can make 4 out of the 6. So this is going to be 6 choose 4.
Oh.
So what's the probability of success? 0.8 raised to the number of successes, 4, times the probability of failures, raised to the number of failures, or means add. She could make 5 out of the 6, so 6 choose 5, which means she's gonna make 5 of them, so 0.8 to the 5th power, times the probability of failure raised to the number of failures is gonna be what? 1. Or she can make 6 out of the 6. 6 choose 6. This I gave you a warning.
Attention staff,
Yes.
if you have passes for the vaccine clinic, please make sure you pass those out before the day is over. And any student, attention students, if you have an appointment later in this afternoon, please make sure you make it on time. Thank you.
All right, so that's our. Now we're done with that. Now you put it in the calculator.
No.
But you're just doing binomial CDF, so it's like quick. So menu, stats, distribution, binomial, CDF, I think it's option B. So menu, stats, distributions, option B is binomial CDF. How many shots is she making total? 6. And then probability of success? 0.8. What's the lower bound? 3. Good. And then the upper bound is 6. Good job. And then you press OK. And that's 0.983. This is 0.983 or 98.3%. All right. Ooh, I don't know what just happened there. The last one is basically the same, but the wording is changed. It says at most 3 out of the 6. So at most means she can make 0 shots, 1 shot, 2 shots, or 3 shots. So this is a probability of making 0 shots, 1 shots, 2 shots, or 3 shots. So you would do that string 3 times. But except the lower bound is going to be 0. And then the upper bound is going to be 3. Okay?
Okay.
So would still be CDF?
The K,
K is 3.
would that still be CDF, the last one?
CDF, yeah, because you have a range of values. So this is binomial CDF.
So for that, like maybe. Okay.
Here, I'll just show you this.
So you have 6, 2, 4, and then on the second one, like the
B?
yeah. So you have 2, and the other one's 4. So would that be the same for C?
2 and the other one is 4? I don't know what you mean.
I need to know this.
Where are you talking about?
For 6, choose 4, and then like you
Yeah,
see.
because those. Oh, sorry. First period, I switched it. But this has to add up. This is the successes, and the successes and the failures has to add up to 6.
Oh, okay, but like, so does it matter where these go? Yes.
Yes.
Yes,
The
okay.
4 goes with the successes.
Okay.
And the 2 goes with the failures because you can miss 2.
Okay. Well, no. Okay, but and then for that, would it be the same for this one?
Well, let me.